That smells like diesel fuel in here.
What's it gonna take to make this 7.3 start right on the ground like this? Not all of it, but most of it.
In this video, we're going to talk about how to wire a 7.3 Powerstroke to run standalone, as well as mention what to keep, what to delete, and what it might take to run the engine in an 80s truck. Stay tuned to the end of the video for my input on what I did to wire the engine in my 1973 F-250. So early model 7.3 Powerstrokes are the easiest to thin the harness down and to run standalone. 1997 was the first year of passive anti-theft, or PATs, so the later model years, like the 97 and newer 7.3 Powerstrokes, will require a reflash and probably some additional wiring. So let's start with our underhood wiring harness. All of the wiring on the engine must stay intact. The whole harness runs from the engine to the square connector on the driver's side. Those wires control the engine from the PCM and IDM. On the passenger side of the engine, there are a few circuits you will want to keep. You need to keep the 3 wires that run from the ECM to the map sensor, the big wire for the alternator, the 2 small wires that turn on the alternator, and if you want to run AC, the power and ground wires from the AC clutch switch. In addition to keeping the wiring that hangs over the passenger side of the engine, there is 1 yellow large wire, ECM and fuse box power, as well as the 2 glow plug wires. The rest of the wiring in the passenger side loom can be cut out and deleted. Make sure to run the small yellow wire from the alternator to the battery, and run the small green wire from the alternator to the key ignition source you plan on using. Otherwise, the alternator will not turn on and charge the battery. On the driver's side fender lies the most critical parts of the Powerstroke wiring harness. There are some key components that you'll need to keep in order to run the engine. Starting with the fuse box, you need to keep the diode, fuses 8, 9, 22, and the PCM and IDM relays. The rest of the fuses and relays are not needed to run the engine. If you pull apart the fuse box and take a look at fuse 22, you'll see a big red-green striped wire coming from it. This wire will need to be wired to your keyed ignition source. If you notice the large pile of black wires that are spliced together, this is your harness ground. Keep those grounds in the harness and be sure to ground them to a good ground. Also, keep the PCM ground that comes directly off the PCM. The connector to the PCM should be left unmolested if you don't have a pinout diagram. If you do know the pinout or have a pinout diagram, you can remove the circuits for the AC and automatic transmission. The big difference in running the Powerstroke in standalone is the type of ECM used and the transmission equipped. The automatic and manual transmissions use slightly different ECMs, and you will obviously need the correct one for the transmission you plan on using. I had an automatic transmission, but then I switched to a manual transmission because of preference. You can use the automatic transmission ECM with a manual transmission, but this can cause some wonky idle and throttle pedal issues, as well as constant engine trouble codes. So the option I went with was to mail my ECM to CP Addicts in Tennessee for reprogramming. About a week and about $190 later, I had a manual transmission ECM. The smaller square plug that is in the loom adjacent to the fuse box is your automatic transmission wiring. You'll need to keep that intact to run the engine with automatic transmission. The other wiring that you will need to run the automatic transmission is the VSS wires from the stock differential of the donor vehicle and the speed signal module located behind the instrument cluster. That wiring will need to be kept intact so the ECM can properly shift the transmission. Otherwise, you can delete it. You'll need to keep the big cable for your battery connections, obviously. I also recommend keeping the starter relay. It makes a good place to attach battery connections, and it only takes one 12-volt wire from the start circuit in your factory wiring to crank the starter. The barometer and intake air temp sensors help the engine run, but it will start without them. I also recommend keeping them. The intake temp sensor is located on the air filter box, and the barometer is located inside the cab underneath the dash. Those wires run directly back to the PCM. The interior wiring harness is pretty simple. There are only a few wires that you'll need to keep to run the engine. They are the wires for the throttle pedal and idle validation switch. And while the OBD2 connector is not needed to run the engine, I recommend keeping it so that later on you can use it for troubleshooting. I also kept the wires for the check engine light and wait to start light. If you're not trying to integrate a lot of the Powerstroke harness into your project, you can always cut off the wiring for the firewall connection and only run the minimum wiring. I choose to use the firewall plug and instead cut the individual wires out that I was not using. The IVS switch has a 5 amp fuse that's supplying power through the red wire to the switch, and then the brown wire runs back to pin number 5 on the PCM. The pedal position switch has 3 wires that are all fed by the PCM. The gray-white is the sensor from the 5 volt from pin 89. The brown-white is the reference output back to pin 90. The gray-black, that one goes directly to ground. So with all the excess wiring removed, you're now ready to wire the engine in your project. Alright, so here's where I want to jump in and add my own 2 cents on how to wire an ignition source. So I have found that the simplest way and safest way to add additional circuits to a vehicle is through an auxiliary relay, similar to this one. So some people try to wire an extra circuit into their vehicle, like they want to add a bigger radio, bigger stereo, or more headlights, you name it. And they eventually or ultimately overload the ignition switch and potentially burn up their switch, or in worst cases, they burn up the whole dang vehicle. So the switch is designed to carry the load of the factory vehicle. So if you try and add more circuits to it, you're going to increase the load going through said ignition switch. So a relay, or this I guess is somewhere between a relay and a solenoid. I'm calling this one a relay. A relay can carry a much bigger load. So I recommend wiring in a relay that is triggered by the ignition switch. So first what you want to do is you find your 12 volt. You want to find your 12 volt output on your ignition switch and cut it. Then you splice the wire from the switch to your new relay. So that becomes this yellow, little yellow down here, this guy. That becomes your trigger wire. On the load side of the relay, the big 2 poles here, you can add as many wires as that. You can add on the load side of the relay, these 2 big poles here. You can add as many circuits as you want, as long as you don't exceed the amp rating for the relay, and the supply from the battery has to be big enough. So if you run one small little wire on the battery side, and then the load or the circuit side has a million wires coming off it, this wire is going to get really hot. So you want to make sure, that's why I'm running 2 here, you can see. You want to make sure you run a big old wire from your battery to the battery side, and then the load side you can add as many circuits as you can carry through the relay and through the wiring. That way you don't create excessive heat and burn the whole thing up. So one of the circuits you're going to want to run from the relay is the power supply to your vehicle's original ignition output. So when you turn your key on, the on position, that's going to turn power on to your circuits. And so if you cut that wire and run it down here, you're now turning on all this stuff. So one of the circuits you need to turn on now is the wire that goes back to your original cut, and it splices back into your factory wiring. So you turn your key on, all the factory stuff works, but the additional stuff is now being turned on at this source. For this engine, the other circuit you can run from the relay is keyed 12 volts. The keyed 12 volts that you need for this wire right here, the big red-green wire, this guy. That's what turns on the ECM when you turn the key on. So you definitely, I'm running that to this relay right here. So that's all it takes to wire this engine to run standalone. I got some other wiring info now I want to share with you.
So if y'all are at the junkyard and you find a 7.3 and you end up buying it, like I did with this one, there's a few things you're going to want to keep. Basically the entire engine harness. So everything that's plugged to the engine, all that runs to this master connector right here. So all that needs to stay. And that includes your glow plug wiring. Your glow plug wiring is integrated into the main harness because it's controlled by the computer. And this is your manifold absolute pressure sensor, and you definitely need that because, again, that's another thing that the computer needs to see, and it's connected with a line that runs down to the manifold, so you're seeing boost pressure. The engine plug goes right there, so you unbolt that and pull that out. You can unplug this guy. This is off of, I believe this is for the vacuum system. Don't need that. But these computers are extremely important. Don't cut any of this stuff just yet. You want to save all that, and it's a pretty short shot to this box, so honestly keeping this all intact is important. This loom here we're going to go through, and then this loom here is the breakout junction into the firewall. So the firewall will be right here. So also it requires a screw. It unplugs, and that allows you to separate this harness from the dash harness. But this side, we're going to go through and deloom. Speed signal. That gets sent to this box back here in the speedometer cluster. So you need, at minimum, the speedometer for the automatic trucks to work, because the speed sensor goes to this, and then it goes from here to the PCM, and it gets converted into a signal that the PCM reads for vehicle speed. You need a throttle pedal. These are electronically controlled. So there is the idle validation switch, which is this plug here, and the throttle position sensor, which is right there. So I guess it's the throttle pedal position sensor. So I cut these because this came out of another truck. You want to make sure that, I believe the Super Duties have a slightly different pedal than the OBS trucks. So you want to make sure you get an OBS pedal, or else the wiring colors might be different. But honestly, if you have an idle validation and a throttle sensor, it should be the same. But just give yourself enough room when you cut it. If you're worried about wiring, I would recommend pulling the whole dang dash out if you got the opportunity to. Do you need the actual dash? No. But all the wires are loomed and run underneath the dash. So that would be easiest thing to do. And then you can take it home and pull it apart in the garage nice and slowly, as opposed to trying to do it at the junkyard. That's what we did here. So you're also going to need to, I guess you technically don't need it, but it's really, really useful is to have the OBD2 connector and the wiring for that. You're going to need the plug for the dash, this for the speedometer, and this is for the actual instrument cluster. You can use this if you want to use the original cluster, but the most important one for automatic trucks is this guy, because this is taking the VSS signal and running it into the speedometer. I like reusing the fuse block, but you don't need it. This here is your ABS module. You don't need that. Alright, here's an important junction we're at right here. So here's the plug. Here's the female side of the plug that goes up to the alternator wiring. So this is all you need for the alternator wiring. You can just unplug them and undo them here at the, I believe this goes on the starter relay. This basically just needs to go to the battery. This is a battery terminal. So you can unplug them there, because we could cut these wires. There's two wires here that go to the air conditioning stuff, and then there's your idiot light wire on the dash for the alternator. Basically, when you key up, you turn on the alternator, and that allows it to charge the battery. If you don't have that wire hooked up, the alternator will never power up and start charging when you start the vehicle. So you need to keep that wire. So if you're pulling this out of the junkyard, you could just unplug, unbolt, and pull this off, and now you've got what you need for the alternator. The first major cut I made was right here. All this stuff is in this pile, and it's just the turn signals and the headlight. And there are some plugs. These plugs do not go to the ECMs or any of the sensors. They are for body stuff, and since this is not going in another OBS truck, the body plugs are not going to work. So I just cut all those off. This is my pile of garbage. If I need wires, I can come in here later and pull some wires out. It's always good to have extra wire laying around if you need to run something. But all this stuff is not needed for the truck to run. The next step for me is to go into the underside of the fuse box and pull the wires out that I don't need for the fuses. And then also, this is the IDM plug. You're going to want to not modify that at all. But I'm going to unloom this to the ECM, and there's a ground wire for the ECM. We're going to make sure that any unnecessary unused stuff, we're going to look at our pinout on our diagram of our ECM and run these wires back, and the ones that we don't need for like the headlights and such, we're going to just pull out of the ECM and depin it. Whatever you do, don't cut this. This is your air intake temp sensor, and so it's a gray and a gray red, and it's further back in here. It's on its own piece of loom, so all this stuff is separate from that. So just don't cut him because you're going to need him too. Alrighty, so let's have a little recap of what's going on here. So the headlight wiring you can cut out. There's all that tape and junk. You need your intake air temp sensor. That's right here. This is your fuse block, and it mounts in here. If you get a screwdriver and push on those clips, you can pull it out and separate it. Same thing with the main engine harness. You can push a pin right here and pull this off. Makes it easier to get at because all the wiring underneath, you gotta pull or de-loom it. And then there really isn't much you want to cut in this part of the harness. So the headlight wiring goes back into the loom, and some of it goes into, all of it goes into this junction for the firewall. And so everything inside the cab is on this end. So those are the only wires I've chopped are right here. And the all the PCM wiring is still here in the PCM. I did get a little bit overzealous, and I had to cut some ground wires. All these are grounds, and they're all spliced together in one ground. If you look at the wiring diagram here, all of your PCM grounds, your IDM ground, all of your body grounds are all spliced here S106, and then they go to that G108. That is this bundle to this guy. So you want to be careful and not cut anything, because otherwise you're gonna have a heck of a time putting it all back together. But I did end up making that mistake and cutting all my grounds, but they're all bundled together and they should be easy to just solder back together, or I can just solder on a ground lug. Again, this is going in a different vehicle, so the grounds might have to get lengthened anyways. But I de-loomed it. I pulled out the headlight wiring stuff and the wiper switch, the wiper washer, pump, and everything else that you're not going to need. I pulled all those out and I cut those back. Then I also cut out this is for the heater controls, or the heater blower motor control. And I'm going to pull that fuse out of this box by taking these tabs off and pulling the fuse out and then pulling these links out of it. I might cut these back and just save them in case I want to use that for a relay for something else. But for right now, I'm going to just clean this up. But you don't need this stuff either. Alright, so this is the body harness connector for the ECM and the engine control functions and stuff, like your idle validation switch, and the instruments, and that's about it as far as what you need. This is actually more wiring than you need for making this engine run, but I want it to be kind of integrated, and also I want to use all the pins on this plug, so that way I've got one giant loom and that's it. So as you can see, I've made some deletions here in the harness, and pin here, and we can run our Dakota digital gauges, our VSS from our axle. We can run any of the accessories that are aftermarket on this truck through this harness. That way it'll look really clean. It'll be just one connector. It'll look almost factory. But now the plan for me is I'm going to get these brake lines all done up, so that way it's all connected, and we get the fuel lines finished. And then I'm going to take this connector and I'm going to cut a hole right here where this hole is, and it's going to live right there because you can see where the inner fender lives. So this will live right there. I'll have my big harness connector. I can work on this side of it, these wires, and on this side with those wires. More progress. This might look intimidating to some of you, but since I've been through this about a million times now, I kind of know what's up. So this strand here is going down to
an 80s fuse block, and these are just additional circuits I've added in. So now that I've cut them out and pulled them out, I know that they're not going to anything stock as far as the 73 wiring goes, so I'm not worried about cutting these off and starting over. But here are some wires. Again, I'm going to pull the fuse block down there. I'm going to unscrew it and pull it out and go through it, and I'll hang these loose so that way if I need a fuse or a relay, I can just tie into one of these lines and make that work. But this is all stock harness stuff. And then here are my senders for my sensors and stuff. And then I got my lights and my brake and all that. So these all go into the gauge interface panel. So they're all kept together. That includes this guy and this guy. So that's all instruments. Then this line runs over here. This is a light that comes from, it's basically for the light bulbs for the interior like instrument panel lighting. So that one's a spare. The reason why I know that's because in the harness it's blue and red. This is the switch power for the stereo, the aftermarket stereo I got. So there's that plug there. These are tied into all the other the stereo, the power, the constant power, the ground, the power on, the amp control, all that nonsense. There's the blue wire that's part of the signal from the amp that's behind the seat, and that runs up under the floor, and that's what this blue wire goes to. Here are the heater controls, and I had a fuel tank selector switch because I had dual tanks at one point. I just chopped those two wires. I figured out which was which. This is the back sender, and I just teed, or sorry, this is the back sender, so I just teed these together. So this kind of just hangs out back here. It doesn't do anything. There's the wiper motor. The wiring for that is stock, so I'm not going to mess with that. And then the wires in this loom here, this is factory wiring again. It goes up into this conduit, and it pops out over here, and that's what this plug and all this stuff as far as all factory loom. And there's your starter solenoid switches. And then this big wire is the constant, or not the constant, but the main feed for the amp. So that's just hanging out. It's run under the floor and stuff. So that's going to have to go through the firewall to the battery. And yeah, there's some heater connections and a couple of relays and fuses under here. But that's all stock wiring. I'm going to probably untape it, and then when I run my new wiring, I'm going to loom it in so it's all one giant loom. And then this is all the stuff that I yanked out, and it's just accessory stuff and some powers, and that was for the gauges and for the A-pillar pod gauges I had. But again, I'm starting over. I got a complete new clean slate I gotta do, so I pulled all this out. I gotta run it all new stuff anyway, so there's the wiring delete. Most of the wires in this breakout connector I have reused to splice in either some functions or some switches or the headlight, taillight wiring for the stock 73 harness. Like I said, it's cleaner. I wouldn't have enough space here for the PCM plug and for this breakout connector and the stock 73 grommet. So I just wired everything through here. It took a little bit figuring out, but basically any wire that's not being used, you can cut, and then you can either continuity check it on the other side and figure out what, this color wire. They're all the same color on either side. So like this green wire is the same color on the other side of the breakout connector. So it's not too hard to figure out, but if you're trying to find a wire that's spare, I'd recommend doing a continuity check. Okay, so we've got this big red-green wire. This big red-green wire is the only wire you need to turn on with the ignition on. And with that wire in this harness, I've got him wired up here. So this is another solenoid. I've got power coming in from the battery. I've got this wire here. This tan wire here is getting power whenever I turn the key on. This is for the automatic transmissions. This color wire is your
neutral safety switch. And the manual trans computers, this would be a different color, but it would be your clutch safety switch. My Dakota Digital wiring, they give you all these adapter sensors. I had to make an adapter right here. It's just a piece of brass that's threaded to 7/16 fine with a bush for 1/8 inch pipe. That's my oil pressure sensor. It's right on top of the high pressure oil pump reservoir. That gives me oil pressure, so I know what the oil pressure is. The ECM does not need to see that. It's just this sensor here just goes to the dummy light on the dash on the stock Powerstroke harness. The ECM does look at coolant temp, so I had to make this T-fitting here for my coolant sensor for my gauges, and so my coolant temp is going to be right here after the thermostat opens. So this will be a little bit off compared to the actual coolant temp sensor, which is down there. It's a bit of a rat's nest in here, and I would not say I'm the proudest of it, but at the same time, the advantage to having a rat's nest is that when you want to do electrical work, you're not stuck in the dash here. You can do it all out here, or you can get to it, and then tuck it back in there. I will say that nothing is going to hang up or touch my wiper arm linkage, and nothing's going to touch my brake or my clutch linkage, or my throttle linkage. I don't really have throttle linkage, so that doesn't really matter anyway. So the wires aren't rubbing on anything, they're not touching anything. I can still get to everything pretty easy. It's not going to win any awards for being clean, you know. Like your stock harness is pretty clean looking, but your stock harness doesn't have a bunch of extra looms for a bunch of extra junk. So anyways, wiper, headlights, light for the message for wiper lights on the bezel. My ECM tray, I took an ECM tray out of a 90s Ford, and then I just modified it a little bit and kind of have it sort of half-ass mounted like this. I can get to the back of it and still have space to install a chip tuner if I wish to, and I will probably down the road. Every Dakota Digital VHX instrument system comes with this control box. It's pretty straightforward. So the sensors that they supply you with are going to be your oil pressure sensor and your water temp sensor, as well as a speed sensor. That's an option. I originally ordered that and used it, but now that I'm running a different vehicle speed sensor, I'm not going to be using it. So we'll start with that. Speed sensor, these are my two wires from my speed sensor. Now, the Dakota Digital will require you the speed's positive wire. It supplies 12 volts to their sensor, but since we're using a different sensor that runs off of a tone ring on a ring gear, all it's going to do is just generate its own signal. So you want to just wire in your positive wire. I mean, they're just a 2-wire. You can do them however you want, but you want to use speed negative and speed sender. Run those 2 wires, tighten them down. Now you got your vehicle speed sensor. You can have a warning. It could go to a buzzer or a light on the dash or whatever. It can come on if you have some other thing like maybe seatbelt light or whatever, but I'm leaving it blank. Tachometer wire. This wire is coming from the tach on the ECM. I'm going to try it this way. The other alternative, if you don't have an ECM tach output, or if you have the incorrect signal, because sometimes these are kind of finicky about what type of signal they want. If you have any problems with getting your tach to work, you may need, and this is for diesel engines, but this is a DSL1E, and it is a diesel tachometer interface. And what you can run it off of a couple of things. You can run it off of a timing sensor, like a magnet sensor on the front of the engine on the pump gear, or you can run it like I did. I ran it off the alternator. So this takes a constant or switch 12, a ground, and then you've got a ground for the sensor, a signal in, and then you've got an output. And depending on what kind of output you're getting, it's going to be different based off of what you're running your output to. For this, you'll be running the normal output. But anyways, I'm going to try this. There's different setups that you can do
to get the tach signal to be either a 4, a 6, or an 8. It goes up, I believe, up to 16 cylinders. I'm going to try that first before I try breaking this out. I'm hoping that I can just get the ECM tach signal to work properly. Accessory power is so when you turn your key on, you need a wire going from your ignition source or whatever to accessory power positive. Constant power is constant right off the battery. And then big old ground. Your instrument panel uses a display cable, like a Cat 4 or 5, I forget. It comes with it. So it goes from here to your instruments. Makes it really easy. You can just put this kind of remotely and tighten it down and have all this out of the way, and then you're not running all these wires to your instrument panel, and it makes taking the instrument cluster out pretty quick and easy. Dim positive, that's so when you turn your lights on, you want the instruments to light up. You're going to find your wire in your harness that when you turn your lights on, it comes up. All these wires here, except for 4x4 and weight, came out of the 73 harness. So we've got our brake warning, which is, for me, it's the low fluid level switch on the master cylinder. When it gets low, I'll get an alarm. So that's that wire. Check engine comes from the ECM for the Powerstroke. High beam, left turn signal, right turn signal. 4x4 is a switch on the transfer case. There's a little message that'll pop up. It'll say 4x4 on. So I got a wire running to that. Gear wire, I believe, is for an automatic transmission, so I'm not using that. Wait to start light, and then cruise is a cruise signal from the ECM. I'm not using cruise control because I've got an automatic transmission computer, and I don't think it's going to work properly. So I'm keeping my cruise control off, so don't need that wire either. Now, you wire all these up, and then it should work. And if you're wondering how to upgrade to a delay wiper switch, well, the early 80s, I think it was 80 to 1980 to 1987. No, it might be a little bit later than that. It might be 87 or 88. When they went to the different steering column with the wiper switch on the stock, that obviously won't work. But before that, they have a delay wiper, and all of them do. All the 80s through, at least all the ones I've seen in the junkyard at least have delay wipers. So you need the switch out of the truck. So it's the same exact switch, it's the same exact threads, everything. Rod's the same. Even the knobs are almost similar. You can change them out, like I did. So you have your switch here. Looks pretty similar, except for it's got a ground on it. You want to make sure that's a nice, good ground. So I ran it up here to some metal I sanded off, or some paint I sanded off, and made a good ground. So you need to ground this part of the switch. But then this plug looks like your stock plug, but it runs down to this box. You need this box. This box is what causes the delay function to happen. And the important thing about these boxes is that they are very sensitive to shock. That's why it says do not drop on there. So they can go bad, and if they go bad, your wipers don't work at all. And I've had that happen to me. So this is the second switch I've gone through. You can buy those, but they're really expensive. In my opinion, the way to get them is out of the junkyard. So it plugs in though. Let's see here. Down here, this is the wiring to your stock wiper switch. So you just replace the wiper switch with this one. You need this harness with this box, and then it's got the pigtail connector for your stock switch, or your stock wiring to your stock motor. So the wiper motor, I have not changed. It's the same wiper motor, and it works just fine. I haven't had any problems with it. You want to make sure if you mount your switch, you want to mount it in a spot that's very isolated from vibration. I just let this thing hang on the wiring loom, and it doesn't seem to care. So all you gotta do is buy the switch, screw it in, ground it, and then plug it in, and you're good to go. Now you got delay wipers.